everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into an amazing agentic framework of LangGraph. So, this LangGraph agentic framework is booming a lot nowadays. We'll be looking into it from basics, then we'll move forward step by step and we'll master this particular LangGraph. We'll be building multiple agentic flows. Now, in this particular video, we'll be looking into what exactly is this LangGraph framework, what it does, like how it is different from the other agentic frameworks, and what special things it has. Now, without further delay, let's see the definition of LangGraph. So, by the definition, it's a library, a Python library or a JavaScript library which is built on top of LangChain. I hope you guys are aware about LangChain because we have seen a lot about it in the previous videos of this particular series of generative AI. Now, this is for creating stateful multi actor applications with large language models. Now, very heavy words are used in here, stateful and multi actor applications. We will be looking into it in the further slides. But for now, just remember that it's a library which is built on top of LangChain, which is used for creating stateful and multi-actor applications with the help of large language models. Now, this LangGraph, you can see the word contains a graph. So basically, this ideology extends the typical ideology of the directed acyclic graph, that is the DAG, which contains nodes, edges. So basically, this extends this DAG approach by introducing the cyclic computation. So now, here, whatever graph is going to be built, that is typically inspired by this DAG, and it can also contain cyclic computations. Whatever processing will be done will be totally represented with the help of that particular graph. The entire flow will work according to that. Now, what exactly is the core benefit of using this? So, the core benefit is that it enables iterative agent like behaviors where an LLM can loop through actions and decide what to do next. So, basically, here you can just imagine it's a smart graph, a graph which will execute autonomously, automatically, based on the decision making, which will be obviously decided by the large language model at the runtime. But the flow, how it is going to work, we are having the full control of it. So it can be iterative, it can be cyclic, and here the entire behavior will be agentic. So I hope by just listening to this particular explanation you might have got a basic idea of what exactly LangGraph is. We'll now be looking into the details of it, like what this stateful actually means, what this multi-actor applications actually means. With the help of an example, we'll be looking into it. So first we'll see the components of the LangGraph framework. So the components are very simple. First component is node. So basically the node is the basic building block of LangGraph. You can say that a single node is the basic unit of LangGraph. This particular thing represents individual computation steps, that is, the processing input, making decisions, interacting with APIs. So basically, you can think a node as a particular function. What it will do, it will simply take an input, it will process it according to whatever logic you define. It might contain external APIs through which it can send that particular input, fetch the output, and then it outputs that particular response. It has the capability of processing the input as well as making decisions. So I hope the node is clear. You can simply, so an example of nodes would be like this. You can see we have four nodes over here: node A, node B, node C, and node D. Nodes are separated from each other, they are independent, and hence this is not a complete graph. To make it complete, we have another component of LangGraph, that is the edges. So what exactly this edge is? It connects the node and define the flow of computation. So as we already have discussed that a particular node will simply process the input, it will do some computation and then it outputs. But here the edges will define the flow of computation, how the computation is going to be happen, which node has to be executed first, which has to be executed next, or whether a particular node has to execute again and again till it meets some condition. The entire flow is decided by the edges. It supports conditional logic. That is, it dynamically determines the next node based on the current state. So as I said that the control of computation flow is in the hands of edges, but it is totally determined with the help of the current state. This is very much important. The state here plays a very important role. In the next slide, we'll be looking into what exactly a state is. For now, to make this particular graph complete, I'll simply draw edges. You can see now the flow is decided over here. You can see node A, first comes the node A, then comes either node B or node C. Whichever of them executes, finally it will meet the node D. So this is a simple complete graph. Now I hope the individual rules of nodes and edges is clear to you all. Now we'll complete this particular explanation, that is how the next node is determined based on the state. We'll be looking into it with the help of an example, and also we'll see what exactly a state is. So moving on to the state. So the next feature of LangGraph is the state management. Now you might be wondering what exactly a state is. Let's see that. So we'll see the state graph concept. The graph maintains a state that is carried from one node to the next. So if you look at the previous example only, we had four nodes, we had edges. So basically that entire graph will maintain a common state throughout the flow. Whichever node is having the control will also have the access to the state. Now how it works, let's see. Now as you know, the node will process something, so with the input it also receives the state. So each node receives the current state, performs its task, then updates and passes the state forward. So basically you can think state as a notepad that contains a set of variables which are predefined, and whichever node gets that particular notepad will simply update the variables inside that particular notepad and will move that forward to the other node. For example, you can just imagine a workflow where the state contains a user input and the intermediate results. Each node over here might add new data or refine the existing information before forwarding it. It ensures that the entire process is aware of the current context. Now this is the reason we maintain this particular state. Whatever may be the conversation that is happening inside our graph, the context will be maintained. The entire workflow that is getting executed will be aware of the context, like in what state that particular session is in. Now we'll be looking into an example which will clear all your doubts regarding state. So let's say we have this particular graph. Over here you can see we have four nodes. The input is the first node. You can see that here this is the starting point of the graph. The first node is the input. After input there is a conditional stage where two edges are popping out from that particular input node. The first is the double and second is the triple node, and then finally these two nodes clubs to the output, and our graph ends here. So let me clear out the scenario. So basically, let's say we have a scenario where the user inputs a particular query. Let's say the query is double the number. Basically the user can put any number, double the number 10. So in this case the flow should go like this. First it should come to the input node, then since the user is asking to double that particular number, so it should go to the double node. As the number is doubled, it will simply go to the output node and the graph ends. If the user puts triple the number 10, then in that case graph starts First, it comes at the input node. Since the user query contains tripling the number, so it will go to the triple node and it will triple. And the logic of tripling that particular number gets executed over here, and it goes to the output node and the graph finally ends. So this is what is the scenario. Now, as I said, that in this entire graph, whatever is defined in LangGraph, we maintain a state. So it looks something like this. It's basically a dictionary. Over here you can see this is the state. Here we have four variables which we are going to maintain throughout this particular LangGraph flow. First is the input. Basically this particular input variable contains the number whatever user inputs. Initially it is set to 0. Then it contains a double and a triple variable. Initially, this is flagged as false because we don't know what user will input, whether the user will ask to double or to triple. Then we'll put a output variable, which will store the output after processing this particular entire flow. Initially, it is set to 0 again. Now let's say the user inputs a query, triple the number 12. Now in this particular case, the the input number is 12 and the user is asking to triple that particular number. So now our graph execution will start. Now as I said, the state will be maintained throughout the particular graph. So this particular state will be forwarded to the input node. The input node will simply grab the number from the query and update the state. So input node grabs the number from the query and it inputs and it updates the state over here. You can see the input variable is now updated to 12. More thing is happening over here, that this you can see this is a conditional stage wherein two edges are coming out from this particular node uh, based on the user query. Now since the user query asks to triple this particular number 12, so it will obviously go to this particular node triple. So as and when the control goes to the other node, with that it also takes the state. So state will come to this particular triple node. Now over here, the flag of triple will be updated. That means this triple will set to true. And you can see the state is updated over here. This triple, since it is set to true, now if this particular flow goes forward, the state, this output node will understand that it has to triple because the flag is set to true. So whatever is the input and whatever flag is set to true, it will use these two and will simply execute. That means it is going to triple this particular number 12 and will give the output. So you can see the state of the output node updates the output variable, that is 36. You can see the number 12 as the input is now giving us the output as the number 36. So this is how the state is maintained over here in LangGraph. So I hope the significance of state management is clear to you all. You might not feel this logical on a smaller scale, but when it comes to large scale applications, this is very much useful. As and when we'll move forward in this particular LangGraph series, you will understand why this state management is very crucial. So I hope the entire features as well as the terminologies that are included in LangGraph is clear to you all. In the upcoming videos, we'll be looking into the different intricate details of LangGraph. We'll be building LangGraph starting from a simple graph, step by step moving forward, and we will see everything related to it. So stay tuned for that. For more such videos, do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.